Okay, so this is a quick look at the new gizmo I'm working on. It's still a work in progress, so there's still things to be fixed. I've got a couple of things working. I started working on the rotation, and it led me to a problem which has been in there since the BTB days. In fact, BTB still suffers from it, and I don't want to repeat the same problem it has. So just to demonstrate this quickly, I've rotated this around the red line there, which is its x-axis, and if I rotate here along what should be its y-axis, you'll probably note or see that it's actually rotating on a global y-axis instead of on that green line. So I definitely will be putting in global rotation and local rotation, but this should be local, and it's not. And it's to do with the way I'm using the rotation matrices, and if you've got a lot of these things and you want to rotate them all in that same direction and lean them over all in the same direction, you should be able to do that with the global rotation. But if you do that, you notice I've just knocked it down here haphazardly. But if you're wanting to replicate a Queensland farm where they've knocked down all the trees and they do it with a tractor with some chain between it, they just knock it all over in one direction, so all the trees should be lying the same direction, maybe with a few dead koalas around them. Anyway, let's jump into the code and have a look at how we're going to fix this. So this is a glimpse into the bit of code that I use and for RTB for handling objects. And this is an instance of an object, so it's where you place it in the scene and stores information about the scale that you've used against this particular object and so on. And so we're going to use a branch of mathematics called Quaternions here, created by a guy named William. He's an Irishman. He did it in 1843 while he was on a bridge with his wife, which is pretty fascinating. I know my wife thinks I'm away with the pixies sometimes, and I imagine he probably was sometimes too, thinking on things. Not that I can equate my ability with his, but I can't understand these. They deal with complex numbers and imaginary numbers, which are just fascinating, but I can't really fully grasp the very fundamentals, but I get what they're used for, which is good enough. So let's look at where we've used this rotation, and we're going to create another property here so we can access it as well, and we're just going to stick a Q on the front there to denote this is a Quaternion, and we want that as a Q, and then this function here is whenever the rotation scale or translation changes, we've got to go and change the matrices that get calculated. So this is the rotation matrix that gets used after applying scale to the object, and then the final transformation for the object is the scale rotation multiplied by the rate translation. So if you know anything about matrices, this is very useful for transforming an object into a position in global settings. And then I've got to do this for each of the children that make up this instance of an object if it's a complex object. But the part we're going to change now is this here. It's no longer going to use that rotation variable. We're instead going to use, and I got to scratch my head for this, rotation Quaternion. That's what we're trying to create, and we're going to use this version of the method and pass in our Quaternion out with the matrix. So that function there is going to calculate that matrix. I'm only a part-time programmer, so you see me part-time programmer for RTB, so you'll see me scratching my head when I'm looking for functions that I think are there, but I'm not entirely sure. So it takes me a little while to do these things, especially if I haven't programmed for a couple of weeks and come back to it. Let's see where else we need to modify this. So we'll just go back. Actually, we've got it here. There we go. We'll just find other places for this, and we'll do it here. I don't think I'll bother with that function for the moment, or that one. This is for writing the object out to a binary file when you save it. This one's for loading from a binary file. We do need to do something here if I'm going to load up one of my projects. We're going to say that we've got to create a quaternion from the roll, pitch and yaw of our old variable, which we will no longer use for calculating, but we will use it when we read in the object initially. I will have to come back to this. Now it's looking for yaw first, so we pass in the y, and then the pitch, I'm pretty sure it's x, I store that in, and then the roll is going to be the last one, z. So that's doing that part of it. I'm not sure I have to bother about this. Yeah, we might as well do it while we're here. Oh, look at that spelling. Let's just rename that so we get that right, and we'll change that to Q and Q rotation. That's because I just copied and pasted, didn't I? The rotation, yeah, let's change that as well. That makes it a bit better. Now getting back to where I was using that, down here somewhere. Let's just do that again. Right, we'll find that. Find all instances of it. Oops. Find all instances of it. There we go. Scroll down. Doing that. Yeah, that's good. That one needs to be changed. Q rotation. Q rotation. Okay, and I think that was about it for that part of it. Now I know when we're rotating it, this is a function that gets called from the interface, and I've dabbled around a bit with the rotation function already, but let's go back to it. I was trying to do it without using quaternions, and it was racking my brain, because if you Google, there's quite a few solutions and none of them quite worked for me. So I'm just going to get rid of that. And we're just going to solve for the y-axis, although eventually I'll make this into a generic transformation. And instead of that Q rotation, we're going to be that local object's instance rotation, we're going to use the Q rotation and set that to a variable. We'll come back to this in a moment. So we create a quaternion, and then we're going to create an axis rotation quaternion. They're very useful for rotating things on an arbitrary axis. So quaternion dot, it's got axis in it. There we go, rotation axis. We'll use this version of it because it's slightly faster than that. Ref of the axis and the angle that we'll do, that's going to be the same as before. And then we'll do an out to our R, which is our rotation goodness. And now we want to get that may already be set to a certain position, and all we're doing is multiplying that by our new quaternion to give us a new rotation. Let's build that, and hopefully it all compiles, and hopefully that's enough to get the very basics running. We'll test that out. Okay, one thing I forgot was that by disabling this, I can no longer rotate along the X or the Z axis. So I was about to demonstrate it, and then I realized we actually need to copy this and do it for the other axis as well. However, instead of y-axis, what we're going to do is just call it axis, like that, and we'll do the same here. This is going to be the y-axis, but we need to pass in an angle. So this here, I'm actually going to probably do a sneaky and just go copy that. Just do this for the moment so that we pass in one more vector, and we just use that same axis. So the reason we need to pass in an axis first is we need to say what axis are we rotating around, and that's what we're doing here. So this is going to be the x-axis, so x will be 1, and I might just get rid of that. I don't know why that's still leftover code from when I was dabbling around. This one was the y-axis, so we'll leave that as is. And this isn't probably the best of coding practice either. Instead of creating a new axis each and every time, I'll probably put these into some constants and just pass those in. Now I've got continue because I was skipping this bit, but we don't even need that anymore. That was the old method, so we can get rid of those and get rid of that and get rid of that. I could get rid of these and have it much more condensed. But we'll leave that for now, and let's build that and see how it goes. Okay, so we're back in the application, and let's test out our rotation now. Well, didn't quite grab that ring. There we go, tilt it over. Now if we rotate by the y-axis, look at that, we're rotating along its green axis. The rotation is opposite to which way my cursor is moving, and I'm not quite sure why that is. But let's just quickly go and see if we can fix that. I'll set a breakpoint there. We'll just start that again, and we'll change the angle to be negative. Untoggle that. Continue. Now, yay! It's matching my cursor now. Look at that. So now it shouldn't matter which axis I grab, that local rotation happens. Awesome. That wasn't too hard to fix. Now I do have more work to do, so I've got scaling working, but I haven't got translation along the red axis there. That's going anywhere it likes. So that's going to take a little bit of work because these trees are sticking to the ground. So if I move that, you want it to translate there, but you also want it to stick to the ground. So it's a little bit of a catch-22. It takes some special coding to do that. And that ball in the middle, you might be wondering, that's for scaling in all directions. That's what I intend anyway. So if you grab this and drag outwards, it'll scale the object not just in one direction, but in all directions at once. Anyway, thanks for watching, and I hope to have this out maybe within the next few weeks or so, depending on how much time I get and how well the programming goes. Thanks for watching.